The back squat is one of the most popular exercises used to create lower body strength, hypertrophy, and power adaptations. The movement is predominantly performed in the sagittal plane and consists of two movement phases. The descent phase begins as the hips, knees, and ankles flex. The body continues to move downward until the top of the thigh is parallel with the ground and the hip joint is either level with the knee joint or slightly below. Ascent comprises of the lower body joints now extending until the subject has reached their original extended starting position. The descent phase begins with 175 degrees of knee flexion and ends with approximately 66 degrees of knee flexion. During the descent phase, the gluteus maximus and the hamstring muscles, biceps femoris, semitendinosus, and semimembranosus, lengthen from the hip and work together to control flexion. The quadricep muscles vastus medialis, vastus lateralis, vastus intermedialis, and rectus femoris work together eccentrically at the knee. Trunk stability and control are derived from the erector spinae, abdominals, and obliques as they are creating an isometric contraction to support upright posture and counterbalance any unwanted trunk motion during the movement. During the movement, the taliocrucial joint facilitates the actions of dorsiflexion and plantarflexion. The gastrocnemius and soleus are the primary muscles responsible for flexion and extension at the ankle, contracting concentrically during plantarflexion and eccentrically during dorsiflexion. They work together isometrically and act as knee stabilizers during the two movement phases of the squat. The participant should position the bar on the posterior portion of the upper back and have their feet shoulder width apart or approximately 35 centimeters. At the midpoint of the descent phase, the hip creates a joint angle with the knee approximately at 106 degrees of knee flexion and the hip at approximately 110 degrees of hip flexion. The flexion of the knee and the hip continues until the participant reaches their comfortable depth at a joint angle around 60 degrees and 66 degrees of hip and knee flexion, respectively. The segmental angles relative to the horizons are made up of the trunk, thigh, shank, and ankle. These angles during the bottom of the descent phase are approximately 50 degrees for the trunk, 19 for the thigh, 59 degrees for the shank, and 56 degrees for the ankle. I will now compare the back squat with the two variations of a front squat and the back squat with wide stance. The front squat is a variation of the back squat, which places the load on the anterior portion of the shoulder region on top of the clavicle and the deltoids. This variation has been shown to be just as effective as the back squat in terms of muscle activation and muscle recruitment. The front squat has a more upright trunk position, which in turn increases the load onto the lower limbs, resulting in a reduction in lower back stress. It has also been shown that the front squat produces lower maximal joint compressive forces at the knee when compared to the back squat. This is also achieved without compromising any of the muscle activity throughout the quadriceps and the hamstrings. With this information in mind, front squats could be more beneficial for individuals with knee problems such as a ligament damage or meniscus tears. A back squat with a wide foot stance is optimal for those seeking strength adaptations in different parts of the lower body. A larger foot stance has been shown to be an effective stimulus to increase inner thigh muscle activity. The participants should stand with their feet over shoulder width apart or approximately 60 centimeters apart. Wider stances and the external rotation of the foot have been shown to increase adductor longus muscle activation, as it acts as a stabilizer, controlling the thigh position during the descent of the movement and aims to keep the body in a straight downward trajectory. A wider footing is preferable for those seeking strength adaptations and development within the hip adductors and extensors. In summary, the front squat is optimal for individuals looking to reduce the force being put onto the lower body joints and the lower back, while still obtaining almost identical muscle adaptations and activations as the back squat. A wider stance is favorable for individuals seeking strength adaptations within the inner thighs and a decrease in the net shear force acting on the knee joint.